Okay, we're looking at example 2, section 5.2. It says that we're supposed to find the extreme values for this function, relative extrema. Remember what relative extrema are? That's just like, you look at the graph, any sort of maximum value that you see, a hump or a valley, those are the extreme values that we're looking for. And if you read about critical numbers and extreme values, you have seen that critical numbers, that's where the extreme values actually occur. So the first thing that we want to find for functions like this, or any function that we're asked to find extreme values, is to find those critical numbers. And so we do this by taking the derivative. So here's the function that we're looking at. Again, it's example 2. That's the function. That's the derivative of the function, power rule. And then here we're just factoring out a negative because that makes this thing a little bit easier to factor. So looking at the thing in the parentheses here, this is how it factors. Again, you need to be somewhat proficient in factoring here, but there's also some online programs you can use that will factor this stuff for you. But if you just Google like factor a polynomial, something will come up. But what we're looking for is two numbers that multiply together to give us 3, right? So 3x squared actually. So we get a 3x and an x, that'll do that. And then over here we got to have factors of 15, so we kind of just do the guess and check thing until we find the right ones. But this is what we get, and then we want to set each of these factors separately equal to 0. So this is going to give us, if I solve this one, I'm going to get x is equal to 5/3. And if I solve that one, I'm going to get x is equal to -3. Okay, so the question asks us to find all the extreme values. So first of all, we need to know, are these actually extreme values? So the way we do that is we set up a table that is based on those critical numbers there. We'll go from -infinity up to the smaller critical number. Then we'll go from the smaller critical number to the bigger one. And then we'll go from the bigger critical number to the end of the domain, infinity in this case. And then remember what we want to do, figure out where this function is increasing and decreasing. This is called the first derivative test that we're doing here. So I pick test values, that's what the TV is. And then I plug those test values into the derivative. So I'm interested in the sign of f prime, sign of the derivative. And then based on that, we make a conclusion about what's happening with the function. Okay? So for the test values, all we want to do is just make sure that that test value is actually on the interval that we're looking at. So x equals -4 is going to work here. 0, if 0 happens to be on the interval, that's always the best choice. And then 5/3, we could put 2 for that. 2 is bigger than 5/3. So there's our 3 test values. We're going to want to plug all of these into the derivative. Okay, so here's the derivative right here in its factored form. That's really what we're going to want to look at. That negative is going to matter here. So let's start with 0 and see what happens. If I plug in 0 here, that number is going to be negative, and that number is going to be positive. But then I've got this negative in front here, so we have a negative times a positive. That's positive. Okay. When I plug in -4, see what happens here. -4 times 3 is -12 minus 5. That's definitely negative. If I plug in -4 here, -4 plus 3, that's also negative. And then we've got the third negative, so 3 negatives multiplied together is a negative. And then if I plug 2 in here, you see what happens. I've got 2 times 3, that's 6 minus 5. That's positive, that's 1. And then if I plug 2 here, it's positive also. But the negative in front makes the thing overall negative. So what is our conclusion? Our conclusion is the function is decreasing on that interval, then it's increasing on the second interval, and then it's decreasing again on the third interval. So what we want to do, or what we want to notice here, is that the function changed from decreasing to increasing at that critical number -3. Well, what does that mean? If the function's decreasing before it and then increasing after it, what does that tell us about what's happening right there? It tells us that we have a minimum value at -3, and we really need to find that minimum value, so we'll have to find the y value as well. For now, I'm just going to put f of -3 because we're going to find that y value by plugging it back up into this function here. And then we've got a maximum value, since it was increasing before this 5/3, and then it was decreasing after the 5/3. Increasing to decreasing means we've got a maximum value. And so that's at 5/3. And then f of 5/3. Okay, so now to find these actual maximum minimum values, we have to now plug these numbers back into the original function. Okay, not the derivative. We're looking at the maximum value of the actual original function here. So we found out that it occurs at -3 and at 5/3, the min and the max. But we need to find out what those y values are. So we need to find f of -3. That will give us the minimum value, or a local minimum value for this. I've got this stored in my calculator, so you can find f of -3 pretty easily. But for you, what you're going to want to do, of course, is actually go ahead and plug that in for all of the x's here in the original function. Simplify that. Can you do that on your calculator? And so I get -26 for that. And then for f of 5/3, and on my math lab, when you get questions like this, you're going to want to make sure that your answer is left as a fraction. So you can actually change decimals to fractions if you have a TI-83 or a TI-84. Just press that math button and you should see a thing that says frac on it. That will change any decimal, or most decimals, into fractions. So when I plug 5/3 into this function, I get that, 670/27. So that's a maximum value. So what we can conclude finally here is that our minimum value is at -3, -26, and then our maximum value is at 5/3 and 670/27. Okay, let's make sure that we've gotten everything that the question is asking for here. It just says find all the relative extrema. We found them. There's the relative minimum value. There's the relative maximum value. We don't actually have to graph it, but if you want to graph it on your calculator just to verify that this is what's happening, feel free to do that.